You know, when we think about construction, we usually think about building things up. But what if the real future of building is actually all about taking things apart? Today, we're diving into some fascinating research that explores how we can use digital tools to turn our biggest waste problem, construction and demolition, into one of our most valuable resources.
But look, before we get into the really cool solutions, we have to understand the sheer scale of the challenge we're facing. And trust me, the numbers here are absolutely eye-watering.
Just look at that number for a second. 30%. That means that nearly a third of every single thing thrown away in the EU comes from building sites. That's not just a small problem, it's a literal mountain of discarded material. And what's really wild is that the waste is just the tip of the iceberg. The industry eats up half of all raw materials, uses over 40% of our energy, and pumps out more than a third of all greenhouse gas emissions. It's an absolute giant with a massive appetite.
So this just forces you to ask a really important question, right? Is all of that stuff we call waste really waste? Or are we just looking at it the wrong way? What if our cities are basically gold mines of resources just waiting to be tapped?
And that question? Well, it leads us to a totally new way of thinking about the entire industry. It's a vision that's built on this really powerful idea of circularity.
Okay, so on the left, you've got the old way of doing things, the linear model. We take resources from the earth, we make something, we use it, and then we throw it away. It's a one-way street straight to the landfill. But the circular model on the right, it flips the whole script. Materials are kept in a closed loop. They get reused, they get recycled, and they never ever become waste. This is the big idea behind a circular economy for construction. So the big question is, how do we actually get those materials back into the loop? Well, the key is to stop thinking about demolition and start thinking about deconstruction. This has nothing to do with wrecking balls and dynamite. No, this is more like surgery, a careful, piece-by-piece disassembly of a building to save every single valuable component for its next life. And this right here, this is the ultimate goal, the circular building. It's a building that's designed from the very first day with its own end of life in mind. You're making sure its parts can be easily recovered and reused, closing that material loop for good. Now you might be thinking, okay, tracking every single nut, bolt, and beam in a massive building for future reuse sounds incredibly complicated. And you'd be right. That is, it would be, without the power of digitalization. This is where a technology called Building Information Modeling, or BIM, is a total game changer. Think of it as way more than just a 3D blueprint. It's a smart digital database where every part of a building, every single beam, window, and pipe has tons of information attached to it. Not just its size and shape, but what it's made of, who made it, and even instructions on how to deconstruct it. So basically, what BIM does is create a digital twin of the real physical building. This digital copy can live on for decades, acting as a complete instruction manual for the building's entire life, all the way to its final, careful digital deconstruction. All right, so the vision is there, and we've got the digital tools like BIM. This brings us to the most important part of this review, the results. If this is such a fantastic idea, why isn't it happening everywhere? What's actually holding the industry back? Let's get into the key research gaps this paper identified. So the research found some major technical hurdles. First, there's no global framework, so everyone's kind of doing their own thing. Second, the software tools don't talk to each other. The BIM software used for design is disconnected from the tools you'd need for end-of-life planning. That means there's no standard way to pass along all that crucial deconstruction info. And finally, most of the solutions we see today are small-scale, one-off projects that are really hard to scale up. But honestly, beyond all that tech stuff, the research pinpointed a core conceptual problem that is even more interesting.
And this is it. This is the conceptual dilemma at the heart of the problem. It's a classic chicken and egg situation. Do you need architects to start designing new buildings that are easy to deconstruct to create a future supply of materials? Or do they need to wait until there's a huge supply of salvaged parts already available before they'll change how they design? Right now, it's a standoff, and it's really slowing things down.
So how do we solve this puzzle? How do we break the deadlock? Well, just understanding these research gaps is a huge first step. It actually gives us a clear roadmap for how to move forward and start building the urban mines of tomorrow. This is the dream workflow. Step 1, the BIM digital twin guides a super precise deconstruction. Step 2, all those salvage parts get cataloged in a digital material bank. You can think of it like an online library or an eBay for reusable building parts. And then, step 3, Architects use BIM to design brand new buildings that are specifically made to incorporate materials from that bank. It's a perfect, seamless loop.
And the really big takeaway here is that once you connect all those digital dots, you fundamentally change the entire equation. Buildings stop being just consumers of resources that end up as waste. Instead, they become temporary storage banks of valuable materials, ready for the next generation of construction.
And I really want to leave you with this powerful quote from the paper because it just captures the whole vision perfectly. Cities and buildings are regarded as urban mines with valuable materials to be further reused. That idea changes everything. Our buildings aren't just where we live and work, they're the mines of tomorrow.